back to Learn to Burn with Practical Machinists. We're actually going to be setting up an actual job and walking you through the importance of a good setup on the EDM and how to put in some very simple features, but can't do them without EDM. Setting this down on the magnet, and I'm going to get this crane out of the way. You got to be careful not to knock your part with the crane. It happens, but you got to be very cautious not to mess up your parting line when doing this. Here we have a condition that we are making a cylinder type shape. This right here is a radius that we had to use to cut it. We're going to burn this area, so we use a larger cutter. But I have two spots, this area here and this area here. And then the electrodes are as shown here. We have the sharp corner we're looking for and the sharp corner. So I'm going to go through the whole setup of putting this block in the machine, setting these electrodes, making the program, and burning these. All right, I am going to have to make sure that this block is now on the magnet. I'm going to turn the magnet on, and the very first thing is you want to make sure this tool is flat. This is totally and completely flat. This is the key to the whole job. If you have sand or a dust or dirt underneath the magnet or the block, it can skew your whole setup, and that will cause you grief all the way down the line. So this job's due by Friday. Today is Wednesday, so the pressure is on to get this burned, do it perfect, and do it fast. So our goal, first and foremost, is make sure that the block is completely flat. So I'm going to set my indicator in the holder, and we're going to come down and check it to make sure that it is flat. And if it's not, I've got to take this back off the magnet and clean it. I'll set it so you can see what I'm doing. So we got it just touching. I have a ruby tip on here because in the EDM, the sinker EDM, you end up having contact issues, and it'll stop the machine as a protection. So I'm kind of overriding it a little bit with that ruby tip. But my goal is to make sure it's flat in both the Y-axis and the X-axis. And this will give me a good indication that everything I do from here will be in line and line up perfect. That looks really good. It's not off more than very much. So one of the tricks that I do is, this is the area I'm burning. You can typically go off the whole side of the block, and sometimes depending on what you're machining, there may be a variation, like the machine might tip or a grind might be off a couple of tenths, but this block looks very good, very flat. So I'm real confident that my burn's going to turn out good. The next thing we have to do is we have to indicate this square. A lot of people want to just use an indicator, tap this around. We're going to use the probe to actually pick up 2 points and call it square, and then we're going to go back and check it with the indicator, because a lot of people won't trust that being good. And I've been burned by it, but I've also come to trust the machine and how it works. So we're going to do that next. Grab an electrode enter, cycle start. So right now I'm just retrieving the probe that's in, I think, tool 10. The probe is going to help me indicate this block in square. A lot of people won't use this feature, but like Ethan showed in our last video, it's a very powerful tool to quickly indicate your job in. And I'm going to show you how that's done. And then we're going to check it, just because I have a lack of trust in some of this technology too, but the more you trust it and use it, the better and quicker you can make your job. I'm getting into the section where we're going to actually use this to align the workpiece in the machine. And you got to look at the number. So it's going to go from left to right on my front surface of my block. So I'm going to hit OK on this. It's going to go, position 1 is left to right. I'm not going to go down in Z, but I'm going to go about 14 inches across. And I can do a little preview, and you'll see it bump, bump. That's what I'm looking to do. So I'm going to hit OK, and I'm going to hit start. Now as it goes in here, it's going to touch that block a couple times, then it's going to move out and move over, and it's going to touch over here, and that's going to establish the angle of rotation, because I did not indicate this block in. I set it on the magnet and turned it on. When we're done with this, we'll check it with the indicator and I'll show you. So this is critical too, to make sure your workpiece is clean, stoned off, and sanded. So this is everything. Your setup is everything when you're burning, because you're hitting the numbers that you're shooting for. And if you have a bad setup, it can really wreck a job, especially if there's lots of burns. All right, so this block is showing me that it's like 0.635 degrees out of square. So the machine compensates for it. I'm gonna hit enter and I accept that. So now that's my new offset in my work coordinate. I always recommend, when you're doing this type of checking with the machine, is to run the whole process twice. It's very common that you will get an error because of a piece of dust on the block. I always wipe it with my hand to make sure there's no dust. I've been bitten by it. You're off like 1/10 of a degree or something very small, and you can't figure out why. It could be very well because of the pickup. So this is critical. Run it twice, and then we're going to check it with the indicator. After you run this twice, before we go to the indicator, is the angle of rotation that it found. If that repeats within 1/1000th like it did, I'm pretty confident that's going to be good. If you run it twice, and after you rub it with your finger and you notice that that number's different, that's when there's something wrong, and you may need to run it 2 or 3 more times just to make sure that's right. Or your block might not be square, depending on what you're working on. So always make sure to check that number and verify it comes out the same, and you will have good luck. And now we're going to verify that it's right, just because of the trust factor. A lot of machinists are looking to hit numbers real accurately. You have to make sure that that block is square. And let's see if it turned out good. All right, we're putting this block, or I'm sorry, the indicator in here so we can check the block. And we just picked it up with the probe, and not quite sure. We're confident that it's straight, other than it did repeat, and I've done this a lot and it works. But I want to verify that it is good. This is a critical part for us, and we want to make sure our customer is happy. So I'm going to set this on the edge. Now, one thing I have to do before I do this is make sure on the control here that the workpiece is active. So a workpiece, it's actually the A side plate, so that is active. I'm just going to double click it just to make sure. Select workpiece active, so I'm good. Okay, workpiece is active. So now I'm going to turn on my workpiece. You can see shows up here. This is my coordinate transfer. So the machine shows 0, and if I move it right now in the X, it'll move just straight to the machine, which is perfectly 0. If I switch to my coordinate work offset, then it's going to actually be skewed. So now as I travel an X, you'll actually see, if I'm against that edge, that it should be 0. So let's go check it. All right, I'm going to move this over, and just till it touches. Normally, if this was, like I said, an indicator with a metal tip, it would actually stop the machine in a safety mode, but I'm cheating it here. And now it's 0 there, so I should be able to move this, and it shows my C rotation off, but that's the actual 0.635 that we saw when we used the probe. And as you can see, that's moving. So I'm gonna show you that that's actually correct. I'm gonna go up and down in the middle here. So that's actually my block. So this is a very cool feature. A lot of people don't like to use it because it can be it could be so scary if you're setting something up that's critical and you have a very small electrode or some feature that you need to hit. But that is very, very good, and I'm going to run with that. Now that we've verified that that block is square, the probe angle alignment worked, now I'm going to put the probe back in, and we're going to pick up center of the block to get my 0, center of it in X and Y, and then I'm going to pick up the Z. And one of the tricks with the Z, and I'll go through that when we get to it, is typically I like to pick up near the burn. So you could pick up off the edge of a block, even though it's flat. I recommend always picking up near your burn. And we'll get that. First thing I'm going to do is set up the Z. The Z is established by my Trode setup sheet. The block I have in here, I'm working off the bottom as my 0, but the very top of it, my parting line is 2.5. So I'm literally going to touch the top of my block with the probe, and I'm going to tell it, instead of 0, I'm going to tell it that it's 2.5 at that point. And we're going to save that data in there, and that'll establish my Z. And like I said, I recommend setting your Z as close to the burning part that you can. I've seen it give the best results out there for me personally, but a lot of times you'll get a block or something that's not perfectly flat, and you have to actually have a reference number from the parting line. That's why I recommend it. It's good practice. Even if your block is totally flat or square, it's still a good idea. It develops a good habit, so when your blocks aren't right, you're still going to get good dimensions when you burn. We're going to get this down close, and then I'll run the sequence to set the tool height and the control. Negative direction, we're going to hit OK, and then we're going to press start, and it's going to touch a couple of times. Just like before, I'm going to save the information that it comes up with, but I always recommend picking it up a couple of times. You never know when you can get dust and stuff like that under it. So here's the Z value. It's 18.331. I'm going to hit accept. Now I'm going to move it up. Z, I'm just going to wipe this off again with my finger. My very first boss taught me to always touch stuff, wipe it off, keep it clean. He said it's just common sense. So now I'm going to run that whole thing again, and I'm going to help to get the same Z value. I believe that Z value was 18.0331. We'll see what we get this time. It is exactly the same. So typically if it's within a couple of tenths, I'm good with it. But this was perfect, it's right on, so I'm going to call that good. Now that repeated in Z correctly, remember on my setup sheet, that parting line is 2.5 according to my print here. So I have to tell it that it's not 0, because right now it thinks it's 0. I got to put an actual value in the control of 2.5. So I'm going to actually run this Z pickup one more time. Press start. Once it's done with that, it's going to technically be touching 0 or my 2.5 number, and then I'll put a manual number in there based on my setup sheet, and I'll show you how I do that. Alright, here was the actual Z setup. So I'm going to go, my probe is in the position I want it to be. My workpiece actual value. So I'm going to go to this, hit OK, and I'm going to type in my Z value of 2.5 and hit enter. So that adjusted my Z value to be correct to my print. And now we're going to set the X and the Y. Set this up. I'm basically going to tell the control that the block is a certain size, and I'm going to put the probe within 1/8 of an inch of center, and then we're going to pick up the center automatically. So I have a 10.8, so I got to be around 5.4 for center, and then it's roughly 18 wide, so I'm going to go 9 inch. So that's pretty much an eyeballed center. And now I'm going to come over and down. So I'm just going to kind of pick a number based on this. So I'm going to come down about an inch and 1/8 from where I'm at. Come over the bottom, top, the X and Y. Our probe in the center of the block, they're pretty close eyeball. We're going to go to the cuboid measurement system on this setup. And the X dimension is roughly 18. So I'm going to put 18.1, just give myself a little buffer. And the Y direction was 10.8, so we're going to go 10.9. And I'm going to go down an inch. Let's go an inch 200 down from Z. So there's a lot of other options. We're basically going to do a pickup in Y first and pickup in X. I believe that's the right direction. So let's see what it does. So we're going to hit OK. Now I always recommend when you press start, just in case you put the wrong number in there, have your finger on the hold or the slow down. So as it's moving, I can slow it down by the dial or speed it up. So when it gets close to the edge, slow it down. And then as it comes down, this is where you can crash the probe, and you always want to be careful here. So I'm going to go slow, watch it go down. It should stop really soon. And that looks correct. So now it's going to touch the block on that side, and then we'll watch it do the other side. The probe is actually rotating 180 degrees to make sure it's using the same tip. In case the probe is off center, this will actually make it compensate center exactly right. So right here is very scary when I have a eye bolt still on my block. That can cause a problem, especially if you have the wrong Z, you can crash into it. So be as cautious as you can. I'm going to take it off over here too. Lots of little things can go wrong right here at the end of a job when you need it to go well. So I recommend taking your time, even though typically you're probably under the gun and there's a lot of pressure. We want this to come out good, so we're going to take our time. Like I was saying before, you want to wipe those spots. And just like everything in here I do, I always do it twice. Make sure your numbers are repeating and you'll have good luck. Looks like our numbers came up for X and Y. It literally turns green. I'm going to hit enter and accept those values. And like I said, we're going to run it one more time. Before we start this burn, double check the numbers. Always double check the numbers. Based on what we measured, our electrodes were roughly a thou and a half tall, which is fine. You can deal with that when you're making electrodes. You just compensate for it in the burn depth. And based on how your burns are going, if you're burning from top down or you're burning from a zero plane, your up might be down and your down might be up. If you've done burning, you know what I'm talking about, but just be cautious on your setup in the Z. And we're gonna get this started and we'll see how it goes. But one of the main things we wanna do is we wanna blend our burn into that cut. So this is real critical, especially when you're doing shutoffs and stuff like that. Fortunately today we're only working on part area, so we have a little bit more lenience. So we'll see how it burns, and I'll get it going. Now that this is just about ready to start, I always recommend, especially on the first electrode, give it a good eyeball check just to see if it looks like it's in the right location and in the right spot on the block. This could be super critical. I've saved many jobs just by taking a second, stopping it, and giving it a visual inspection. Like, hey, the edge of that trode, it looks like it's in the right spot. It looks like it's in the right spot in the Y. I'm feeling confident it's going to be good, so I'm going to let it go. And then also, right when it starts the burn, you'll see the first initial sparks. I usually will stop it at this point, take a look at the burn, and make sure it looks even on both sides. So I'm going to raise it up, go into manual, drop the tank, raise this up. Looks like that is starting right where I want it. There's a little burn in the corner. I'm not sure if you can see it. Try to zoom up on it. That looks like it's in the right spot. All right, now we got more contact in this burn. It was really difficult to see at first, but it didn't look bad. So we're gonna let it burn for another 2 minutes, and then we're gonna check it again. All right, let's take a look at how it's working. Got some stock in there. It looks like it's in the right spot. And we're just trying to, like I showed you, we're just trying to sharpen out this corner. We're going to let it keep going. That looks like it's in good shape. After this first burn to the numbers that we should have, we're looking to blend into this cut, and we're very, very close. I would suggest that we're going to probably go down a little bit more, maybe a 0.5 but you can see it speckling on this bottom. So I'm going to drop it a little bit more. Same thing with this little spot here. It looks like we're very close, but you can see the sharp corner that we made in there. It's not super totally sharp. It's got a little bit of a couple thousandths rad on it. But this is what we're looking to achieve, and then we're looking to blend into this cut surface, which we're very close. Looks like this burn blended into the bottom just like I was wanting. It's speckling very little over here and here. That could be the difference in our CNC versus our EDM, which happens. This is all going to be benched anyway, but you can see the blend onto the floor looks really good, and then it speckles up the side. So we are real happy. This is what the sinker EDM does better than any other machine. If we didn't have the sinker, we would literally have to make an insert that goes in here out of steel. We'd have to have an insert to make that pocket, and you'd have this situation right here. If you had a piece of steel here, that would make the sharp corner that you're looking for in this area. So fortunately, we have the EDM, and we can make that happen using the sinker. I wanted to cover a couple things about burning electrodes like we were doing. Murphy brought up a good question, is why couldn't we take this electrode and double end it to where we could take it and rotate it and you'd have 2 electrodes in one? And that's a very good point. You can do that. We didn't do that in this particular situation, but it can be done, and you could have done it on this one as well. Just making it the same thing on the other side, making 2 electrodes in one. For accuracy, sometimes people don't want to have the error of your machine rotating or the way you've cut it. It depends on how good your machines are at holding your 0 position. So that's one of the reasons we didn't do it on this particular one, but that can be done, and it should be when you have the chance. I'd like to ask the viewers how they make electrodes. Do they double end them if they can? And sometimes you can actually do a 4-quadrant electrode to save on carbon and setup and accuracy. So that's a good question for the viewers. On this particular burn, we only needed 2 electrodes. My question to everybody is, how many did you have to make on your machine? Last episode, we had a question I thought was really good. Someone asked, why didn't we take a form cutter and actually put the diamond shape on this electrode? And the question, or the answer to that question is, we did do that. We ended up trying to cut it, and it's a single flute tool trying to get a very small point. And as we were cutting it, the cutter wore quickly. It wasn't diamond coated, and it also chipped the electrode really bad on every little intersection. So we ended up not using that that method, which would have been a lot faster, a lot easier. But I did want to answer that question. It's a good question, and that's why. For joining us for today's episode of Learn to Burn. Remember to subscribe and like. And just so I make this clear, the setups that are so important on EDM, they apply to every machine that you run. I wish you luck, and we'll see you next time. Welcome back to Zero Tolerance, All right, so I am going to be, stop that.